two solar stills, I guess you could call them. So we're just going to kind of go over how we did it and the idea behind them. So for the solar oven, the basic principle is just that you kind of use the sunlight and direct it to a central point by reflecting the light and the heat to cook food, or I guess really anything you wanted. And so we have one that's made with aluminum foil and cardboard and a lot of other stuff. So what we did is we took this water cooler dispenser and cut it in half, and got a can and just spray painted it black, because black is good for heat, you all know. And took this cardboard, I'll turn around so you can kind of see. It was just a big cardboard box that we had in the beginning, and I guess you can kind of see it flat right here. And we cut it up and cut it flat, and then made it into this parabolic shape so that it would capture the sun, and duct taped it pretty much around here, and voila, you have a solar oven. And so we cooked an egg, and what we did is we had just a regular pot from your house with a lid, and we put an egg in there and used this, a bag like this is just a regular oven bag, and left it in there, and about an hour to an hour and a half later, we have a cooked egg. You can cook pretty much anything on them. It does take longer than normal, but now David's going to talk about our other fun panel, solar oven.
Okay, yeah. The one right there that's painted is called the fun panel. I mean, it's like really simple. Cube-shaped cardboard box, duct tape. We decided to use highly reflective silver spray paint instead of foil, box cutter, and a ruler or any straight edge. And so, we move on to that one. Okay, this is one square side that we cut out with a flap attached. And all you need is two of those. And what we did is we drew 5 lines that are 15 degrees apart roughly from each other. And they radiate out from the flap side, one corner on the flap side to the non-flap side. And using a box cutter, we would, you don't cut all the way through, but you just cut about halfway through on the back side to create the folds. And then on another panel, you cut the flap just halfway, which is how you create this piece that you see here. And then, I guess this would be it. Sorry. And then, yeah, that's how it goes. And here, hold this piece. We would tape it like this. We'd tape this piece down here and this piece right here, and that's your fun panel on a box. So then just paint it like crazy with silver spray paint. And then there were a couple of issues. But a couple of issues using paint. There's aerosols in the spray paint. It's not exactly going with the principles of the class, but we wanted to try it anyways. Slow cooking time with both of these, really. Whenever we wanted to test this thing out, we never got a good window for weather, and so obviously it's weather dependent. And then we're limited to foods that require a minimal amount of energy to cook. And as we found out, high amounts of heat with a surface like this causes things like plastic to stick to the paint. So that's it though.
All right, now Nick's going to talk about the...
Yeah, so we've got an egg, and now we want a nice glass of water to go with our egg. But we don't have any clean water. So we're going to try to use the heat to convert not clean water to clean water. And the basic principle is that when you evaporate water, it leaves all the sediments and other things in the base, and then if you condense it and collect it, then you have fresh water. So what you need for version 2, I'll talk about version 1, which is
The learning experience.
a learning experience, is, well, first you need a solar cooker, because that's how we're going to concentrate the heat. You need a pan or a water vessel, a similar bag to the one we used for cooking the egg, a oven roast turkey bag is the one we used. A wire coat hanger was for version 1, and duct tape was also for version 1. The directions are simple. You just wrap the bag around the water vessel, and I blew into it to just give it a little bit of shape to stop it from like contacting the water and also getting hot on the ends. Tie a loose knot in the bag and place into the solar cooker. So this was the attempt at version 1. What I thought would happen was that the water in this would evaporate and condense on this molded plastic piece, and then it would drop into the collector. But what I found was almost all the water vapor just sort of like exited the thing, and very little condensed on top. And also this peanut can was not really up to withstanding the heat. So then in version 2, we went with this version, and in our test results that we just tried, we had about a plate full of water, and in an hour with a high-strength light bulb, we got this much water. So I don't know how long this is going to sustain you in the desert for, but it's better than zero water, I guess.
Okay, so now you have to drink that. To
Do I really? I will.
And a big thing we tried to do was use things that we could just find, that we just had around,
Yeah.
and not have to go buy anything or get anything. We just kind of used what we had to make these, so anybody could really do it.
For economic and sustainable purposes.
Any questions?
Great. So what is different from, like, say you bought one of these solar ovens commercially? What makes them more efficient? Because from what I've heard, you can cook like a roast or something, and it takes a while. It takes longer than a conventional oven, but not a huge amount of time.
I would say they're more insulated than the ones that we have here. Most of the ones that you buy are really have lots of insulation around them, so that when you are getting the heat in from the sun, it just kind of stays longer. And these aren't very, I mean, these were very, I guess, simple. And we didn't put as much insulation into this.
Now, the one thing you showed was a pot with, I think, a glass cover. Now, that might help hold the heat in once it passes through.
Yes, and the bag also helps with that too. It kind of creates that greenhouse gas effect where you're holding the heat in. And so that was kind of the methods that we used. But the ones that you would buy would definitely have more insulation and actual base.
And they'll use like much better conducting metals also to heat the.
Right.
We were sort of using what we could find around. The
Okay.
backyard.
Okay. Any other questions? All right. Thank you.